Hey everybody, as you can see, it is dark out, which means my child is sleeping, which means shh, or I will seriously come over there. I'm looking at you. Hey everybody, welcome back to Overkill Projects. It's been a little bit. I have been incredibly busy, but in my downtime, or in the time when I should be working, I occasionally hit like Reddit and Stack Exchange. And since I keep seeing the same several questions come up over and over and over, I thought maybe it would be fun to do some quick videos where I just sort of like go over answers to questions that I've seen online. So let's go ahead and just jump right in. The first question is from Reddit Brain Moocher, and he's taking a look at an SPI setup. He has a PIC 16F hooked up to a 25 series memory chip. PIC 16F, really common microcontroller, low power. You should know the PIC lineup. And then the memory IC, the 25 series memory IC. There's a 24 series, a 25 series. You see them all over the place. And now the reason that I chose this question as the first question, other than the fact that I covered this in my SPI videos, which I'll link them here and down below in the description, is that I see this come up quite a bit. Usually it comes up on the manufacturer forums, but this was an easy example from Reddit. So if we take a look at his code snippet down here, we see that he's broken up the functionality into two separate functions. One is an SPI read byte, the other one is a write byte. So this is going to write a byte to the SPI bus. The other one is going to read the input buffer of the SPI peripheral on the microcontroller. So if we take a look down below, this is just a really simple confirmation application. He's just verifying that the memory IC works. So to do that, what he's going to do is he's going to write some data to a known address and then read that address, and hopefully he'll get back the data that he wrote. And in order to do that on a 25 series chip, because these all pretty much work the same, you send a 6 to the chip. A 6 tells it to put it in a programmable mode or write mode. And then you send it another command, which is 2, and a 2 tells it that you're actually going to start writing. And now the command 2 takes a parameter. In this case, for this size memory chip, it takes a 16-bit address. And so he sends in hex an 1802. So hex 1802 is the address he's going to write to. And then he writes data that's stored in T1 to that address. T1 simply contains hex A, which is 10. So he's writing a 10 to address 1802 in hex, and then just below that he's going to send the read command. After he's written to the chip, he sends the read command, which is a 3, and then he's going to send the address, the 1802 in hex. Then he's going to read the input buffer, and he's hoping he's going to find A or 10 on that input buffer, but he's not going to. But the idea here is that his read function was simply reading the input buffer of the peripheral. Okay, so the way SPI works is that both units, both the microcontroller and the memory IC in this case, they both have shift registers attached to them. And the shift register in the microcontroller is going to shift data out on each clock, and the shift register on the memory IC is going to start shifting in data once it's been given the complete command. So that's a command and a parameter. Well, in this case, the command to read was the 3 that he sent to it. Then the parameter to that read command is actually a 16-bit address. So the next 16 clocks, so he already sent 8 clocks that had the 3 on it. He sends 16 more clocks with hex 1802 that has the address. Then he reads the input buffer. Well, now that means that the memory IC never got any clocks after the address with which to clock out the data, right? It needs more clock cycles to start clocking out data. And actually the way these work is as long as you're giving them clock cycles, they keep clocking out data. So what he really needed to do here was send 8 bits, or a single byte worth of clock for the command, and then 16 more clocks for the address, or 2 bytes worth for the address, and then he needed to send at least 8 more bits, 8 more clocks, in order to get data to come out of the memory IC and start loading into the input buffer. If he had sent 8 more clocks, there would have been a byte of data on that input buffer. It would have been 08 or 0A in hex, and he would have been happy. Okay, great. So that was the big problem with this code, but there's also a smaller, more subtle problem that he's got going on here, and that is that you see how he's working the chip select line manually, just using the GPIOs, the input-output pins. So every time he wants to do an SPI transaction, he brings the chip select line low, and then when he's done the transaction, he brings it back high again. Well, then you see that if he does two transfers in a row, then there's no gap between setting the pin high and then pulling it low again immediately after for the next command. So this causes a bit of a problem. This is a little bit more subtle. You have to take a look at the data sheet for the memory IC when you're doing things like this and make sure that you're leaving the chip select line high for long enough that the memory IC actually sees it as being high. And so in this case, if we take a look at the data sheet, it takes at least 50 nanoseconds holding the chip select pin high before we're guaranteed that it's registered as a high signal. Well, the PIC 16F that we're using here has an internal clock of 25 megahertz, which is one clock every 40 nanoseconds, which is less than 50 nanoseconds. So if you try to set it back to back, it's going to set high, but for at most 40 nanoseconds, and that's before you think about, capacitance and rise time and stuff like that. So it's probably even less than that, and that causes a problem. It means that the chip's not going to work the way you expect it to work. So in this case, he also needs to add like a no-op or just really any clock cycle eating command in between setting that pin high and then pulling it back low. All right, question number 2 here is extremely common. This literally comes up maybe once a day on at least one of the forums that I answer questions on, and this is whether to use the Arduino IDE or whether to program a microcontroller bare metal. Okay, so this is like a flame war waiting to happen, and it really shouldn't be, because the question pretty much makes no sense in a bubble. In fact, even the way that it's worded here, it's way too vague. We don't have nearly enough information to really make a statement. It's sort of like asking somebody, well, what is the best car for me, without really knowing anything about them. All right, so this whole thing boils down to what level of control you need. So if you are a professional, so like me, I feed my kid by turning people's ideas into prototypes and products, making firmware and all sorts of stuff. In fact, if you ever want to get a hold of me in that capacity, I'll put a link down in the description down below. But if you do this kind of thing, not to even mention it, but the other thing you give up with Arduino IDE is there's no debugger, and that by itself, for me anyway, once you have used a real debugger, you can't go back. I mean, come on. All right, so here's a question I see come up like really often, and it's for a reason that I have no idea what it's for. It comes packaged a variety of ways, but this one's very specific here. So this guy wants to know how fast he can switch the GPIO pin on and off, I guess controllably, on his STM32F103. So the answer is already in the datasheet. I don't know why people don't just look there. I mean, I know why. It's because the datasheets for these things are hundreds, thousands, sometimes of pages long, and it's difficult to find exactly what you want, I guess. But these days, just download the datasheet or the reference manual or whatever, and just hit Control F and try to find the thing that you're looking for. So in this case, that kind of information is going to be with the GPIO information. In that section, there'll be specifications somewhere. And we see here that the fastest that this thing can switch is 50 megahertz. So that's kind of the answer to his question. But I guess really he probably wants to know how you do that. I think down below in the comments he eventually settles on this idea that you could probably switch it at 36 megahertz because the maximum speed for that microcontroller is 72 megahertz. So if it's going at max speed, it'll switch it every 2 cycles. But that's stupid. Okay, you can make it turn on and off every cycle using timers, right? Because these things have timers in them. But yeah, this actually can go faster than 36 megahertz, right? So it has an 8 megahertz internal HSI, a high-speed internal clock, and you can divide that down from 8 to 2 megahertz. And then there's actually, you know, a multiplier like a PLL that you can multiply it back up by 25 to give you 50 megahertz. Now the system will be working at 50 megahertz, which means you can switch the pin on and off at 50 megahertz. So there you go. All right, so I thought that was going to be very fast, and it actually took way longer than I thought, so I'm going to stop it there because I wanted to read some comments from you guys, because there was some stuff from old videos sort of floating around that I never got around to. Right, so first up is Matse Tuwebi. He commented on the Zoom H5 teardown video, which has been surprisingly not like popular, but I get a lot of comments on it. I guess it's helped people, which is why I do this, so that's great. He had a problem with the mini USB connector on his H5. Something went wrong, something blew up, I don't know exactly, but it wasn't working. And after a few comments, we managed to like identify the part that got blown out. He put in a new one and it works. So how about that? Yeah. I also got a comment from Mike Collins on the STM32 starters guide. I just talked about that a minute ago. He was asking if that's going to be the last in that series, which who knows, but I think not. You know, he asked for something very specific, and I thought, yeah, you know, maybe I will make a video like that. So I'm pretty sure, without reading the entire comment, that he was asking if maybe I would make some videos about how to like follow a datasheet and turn the datasheet into a driver or whatever for your microcontroller. And I think that's a really good idea. So I'm gonna do that soon. That might even be the next video because I like that idea. So actually, if you have any requests for, you know, something that you want to see me make a driver for out of the datasheet, let me know down below. If it's simple enough, maybe I'll include it, because you can see these videos balloon up in size the second you start doing anything remotely interesting. Got this comment from Rana Remote Company, who I guess they make remotes. He was like, hey bro, could you make a video on how to program MediaTek ARM processor? That's a weird comment because like MediaTek, they're pretty tightly controlled, you know, who they give the microcontrollers to. It's hard to find data sheets for those things, so I couldn't do that. But, you know, in the end, I think he was kind of asking, like, how to make your own cell phone or something like that, which I was thinking I could almost kind of do as a video. If that's something that interests you and you want to see me make, like, a hack version of a cell phone out of bits and pieces, let me know, because that could be kind of fun. We got Tiago Fuentes here. He says, thanks for the videos. This is a Zoom H5 video again. He had a problem with the device shutting off. It was a phantom power problem. Apparently the video helped him out. He fixed it. There you go. See, it's like the Zoom H5 one kept saving people from having to buy a new recorder. So that's, man, that makes me happy. I feel the sunshine right in here. And down a bit, we got Dennis D, who says about the 3-cent microcontroller video, more, we want more. Well, Dennis, there will be more. Okay, so before I go, just one last thing. If you made it this far, then you must like my videos. I actually started a Discord server. It's, you know, I'll link it in down below and all that good stuff. And like I said, I've been, you know, answering questions on forums. You want to check, I also have like a Twitter feed and an Instagram thing. I might get a little bit more active with that stuff too, so I'll put the links for those down below. But yeah, there's different ways to reach me. Again, description is the way to find all that stuff out. Make sure that you hit the subscribe button if you like what you saw today, the alerts bell, comment down below, because obviously I love reading your comments. It's super cool. And that's it for today. See you guys next time.